another example. This is going to move us towards significance levels, but let's do one more example just to make sure you feel pretty good about how to do the hypothesis testing. So we're looking at CO2 emissions and a survey done, random sample of 1,041 US adults. Gallup found 53% were in favor of a carbon tax to reduce carbon dioxide emissions. Do these data provide evidence that the proportion of all U.S. adults who support a carbon tax to reduce carbon dioxide emissions different from 0.5? State the appropriate hypotheses and determine a normal approximation-based p-value. I'm going to assume it is okay to just use the normal approximation-based p-value on exams. I try to make it clear if I don't specify that it's okay to just use it, you should test to see if the conditions are met. So let's see. We're going to first of all start out with the hypotheses. We've got the null, nothing special is happening, and the alternate. Here we see that is it different than 0.5? So it's not less than or greater than, it is different. P is the proportion of all US adults who support a carbon tax. This value is unknown. So we're going to see if there's evidence based on our sample that support our alternate hypothesis that it is different than 0.5. So calculate the z-score. Remember, we always start with p hat there. And I'm just going to put this in the denominator. You can calculate this part separately. And we get 1.94. Remember, this is a two-tailed test. So we're going to look at 1.94. We're looking here, and we're looking at everything below the negative 1.94, since it's two-tailed. The p-value, which is the area under both sides of the curve, ends up being 0.0524. Now, a new idea, we're going to stop there and say, okay, if there's a new idea that we want to look at, significance levels. Sometimes researchers use a preset cutoff value or threshold value. It's either way. Either wording is fine, to decide whether the p-value is small. Based on that value, they make a decision whether to reject the null or not reject the null hypothesis. This preset threshold or cutoff value is called the significance level. Now, they are going to set that. They're going to have a good reason for which significance level they set it at, and they will do that before they do any testing, before they take any sampling, anything. So the significance level is denoted by alpha. If your p-value is less than or equal to alpha, we reject the null as not plausible. If your p-value is greater than alpha, we fail to reject the null and retain it as plausible. So instead of saying whether there's strong evidence or moderate evidence, or we just say it either meets the threshold or it doesn't. Commonly used values of alpha are 0.01, 0.05, and 0.1. So here we have the p-value of 0.0524. What's the decision at the 0.1 significance level? Here's what I would suggest doing. I would write down, compare, and then think, okay, the alligator eats the bigger one. I know it's lame, but it works for me. So 0.524 is definitely less than 0.1. So here we're going to reject the null and say we have evidence for the alternate hypothesis. What's the decision at the 5%? Well, once again, we're going to take our p-value and compare it. They're close, but this is bigger than the 0.05. 0.05 is stricter. It's a smaller value. Here, are we going to reject? No, we fail to reject the null and retain it as plausible. Because our p-value is bigger than the significance level that we had found. Bigger than the significance level, sorry, that we had that had been selected before we did this study or before we did this testing. Ooh, once again. So the significance level was chosen before they took any sample. They said at the 5% or 0.05. Unfortunately, our p-value is larger than that, so we do not reject the null and retain it as plausible.